Hi grade 10s, I am doing a revision exercise on naming ionic compounds with you. I am referring to page 83 of your textbook. We are looking at this table and using information from this table to give the formula of certain chemical compounds. So this is your solutions for all textbook and it's on page 83. So normally we would use a periodic table for this as well. You would be using the separate atoms or the positive cations straight from the periodic table for the most part, and then the negative ions are normally from that table that I've shown you. So starting off, anything that's on its own and is not in an ionic cluster or form, that would be straight from the periodic table. If it has brackets with a number, remember those are Roman numerals, then that would be considered telling you what group this ion is behaving like. So for this example, iron is behaving like iron. It's behaving like it's in group 3. The charge in group 3 is +3 if you go back in your workbooks. Right, our next step is to find our so over here, this charge is not -3, it is -1. Okay, so our first step here is to find our lowest common number between 3 and 1. 1 can fit into 3, but 3 can't fit into 1. Okay, so our lowest common number is 3. 3 goes into there once, which means that there will be 1 ion in this compound. So when there's only 1, we do not put that invisible, well, that 1 over there, it would be an invisible 1. Then this entire compound ion has got a charge of -1. If it's just a minus, that means it's -1. So if you see something like this, NO3 minus, O3 minus 1, or NO3 1 minus, all of those same things mean exactly the same. Okay, even though they look different, they mean the same thing to us. So over here we have 1 ion and 1 goes into 3 times, so we need 3 of those entire polyatomic ions. So NO3, that's 1 of them, and to show that there are 3 of those, we would write 3 on the outside as a subscript. If we do not have those brackets there, then it looks like NO3, 3, which actually means 1 iron, 1 nitrogen, and 33 oxygens, and this is completely incorrect and impossible. Right, manganese 2 chloride. Manganese is being told that it is behaving like it's in group 2. Group 2 has a charge of +2. Chloride, straight from your periodic table, Cl, that's the cursive L, and that has a charge of -1 as it is a halogen. Our lowest common number is 2. So 2 goes into 2 once, which means that there will be 1 manganese, no subscript as it is a 1. 1 goes into 2 twice, which means that we will have 2 chlorines. Over here, copper 3 chloride. Copper is behaving like it's in group 3, which means it would have a charge of +3 according to your periodic table, which you have in your book. Oxide. Oxygen is in group 6 and everything there has a charge of -2. Our lowest common number here is 6. Okay, so 3 goes into 6 twice, which means that there will be 2 coppers. Please, it is not a superscript. Superscripts are for charges. Subscripts are for the numbers of atoms. Oxygen, 2 goes into 6 3 times, so there will be 3 oxygens present. Number 4, magnesium bromide. Magnesium is in group 2, so it has a charge of +2. Bromide is in a charge of -1. The lowest common number here is 2. 2 goes into 2 once, so there will be 1 magnesium present. As always, you do not write that 1. Bromide, the charge is -1. It goes into 2 twice, so Br2. Right, aluminium sulfide. You need to be careful with sulf because it can either have a suffix of ide, ate, or ite. Each of these are different. Sulfide is S-2. Sulfate is SO4-2. And sulfite is SO3-2. So paying attention to what you have there is really important. Just checking I'm recording. Right, so answering aluminium sulfide, aluminium is +3 because it is found in group 3 on the right hand side of the table. Sulfide is -2. The lowest common number is 6. So 3 goes into 6 twice, so we will have 2 aluminiums in this compound. 2 goes into 6 3 times, so we will have 3 sulfides or sulfur atoms. Ammonium oxide, this is one of the only cations that you will use in grade 10 that is positive, and it is a polyatomic cation. Right, oxide, that IDE means it's straight from the periodic table. Oxygen is -2. So our lowest common number here between 1 and 2, ignoring the signs, is 2, which means that you will require 2 ammonium ions. You'll need 2 of those entire ions because that charge is not just on the hydrogen, it's on the entire ion. And then 2 goes into 2 just once, which means that you will need 1 oxygen. Right, the second page of our worksheet, potassium sulfide. Potassium is +1 or +1 plus. Sulfide is -2. Our lowest common number is 2. 1 goes into 2 twice, so K2. And then 2 goes into there once, so K2S. Right, number 8, lithium sulfate. The ATE reminds you that it is not from the periodic table. It is from the book, the table that you need to remember. Lithium is Li+1, that is straight from your periodic table. It is in group 1, the alkali metals. So it has a charge of +1. Our lowest common number is 2. 1 goes into 2 twice, therefore it is Li subscript 2. Please note I'm never putting the number of things at the top. The superscript is charge, the subscripts are the numbers of things, the amount, how many there are. Alright, so the charge on this entire sulfate is -2, so we will need only 1 of those. Because there's only 1, we would be having an invisible one on the outside, so we do not need to put brackets in as there would not be a need for them. Okay. Right, so magnesium hydroxide. Hydroxide has a charge of -1. Magnesium is an alkaline earth metal in group 2, so it has a charge of +2. The lowest common number there is 2, so 2 goes into 2 once, so 1 magnesium. Hydroxide has a charge of -1, which goes into 2 twice, so you will have 2 of those hydroxide groups. Aluminium dichromate. Dichromate is one that must be memorized off of the table. Aluminium has a charge of +3. The lowest common number there is 6. 3 goes into 6 twice, so we will have 2 aluminiums. Chromate has a charge of -2. 2 goes into 6 3 times, which means that we will need 3 of those entire dichromate ions. 3 of them. Right, the sodium nitrate. Sodium is an alkali metal. It is in group 1, so it has a charge of positive 1 as seen on your periodic table. The lowest common number here is 1. 1 goes into 1 once. 1 goes into 1 once, so you will only have 1 Na and 1 of those ions. Calcium bromide. Calcium is an alkali earth metal in group 2, so it has a charge of positive 2. Bromide is a halogen and has a charge of -1, has it in group 7. Lowest common number is 2. 2 goes into 2 once, so we have 1 calcium present in that compound. 1 goes into 2 twice, so we will have 2 bromines present. Right, permanganate must be memorized off the table in the textbook. Potassium is an alkali metal. It has a charge of positive 1. Again, our lowest common number is 1. So 1 into 1 is once. 1 into 1 is once. So KMnO4. And our final one, calcium hypochlorite, calcium is an alkaline earth metal, so it has a charge of positive 2. Hypochlorite is capital C L, but a cursive L, O, and a -1. So our lowest common number is 2. 2 goes into 2 once, so 1 calcium, and 1 goes into 2 twice, so we will have 2 of those, calcium hypochlorite.